Welcome to our exploration of force and the laws of motion. In this chapter, we'll unravel the mysteries behind how objects move and interact. Force is a fundamental concept in physics, influencing everything from the way we walk to how planets orbit the sun. Understanding force helps us make sense of the world around us, whether it's a soccer ball being kicked or a car accelerating down the road. Throughout this video, we'll break down each law of motion, discuss real-life examples, and see how these principles shape our daily experiences. Let's begin our journey into the fascinating world of force and motion. Force is simply a push or a pull that acts upon an object. It can cause an object to start moving, stop, or change direction. We encounter forces every day, from opening a door to lifting a book. Forces are measured in Newton's N, named after Sir Isaac Newton. The amount of force applied determines how much an object's motion changes. For example, pushing a heavy box requires more force than pushing a light one. By understanding how force works, we can predict and control the movement of objects in our environment. Measure force, we use instruments like a spring balance. When you pull on a spring balance, the spring stretches, and the scale shows the force applied in newtons. This simple device helps us quantify how much force is being used in various situations. For example, weighing a bag of apples or measuring the force needed to pull a toy car. Accurate measurement of force is essential in experiments and engineering, ensuring safety and efficiency in designs. Newton's first law of motion, also known as the law of inertia, states that an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an external force. Imagine a soccer ball lying still on the ground. It won't move unless you kick it. Similarly, a rolling ball will keep moving until friction or another force stops it. This law explains why seatbelts are important in cars. They keep you from continuing to move forward if the car suddenly stops. Let's look at a real-life example of Newton's first law. Picture yourself riding a skateboard. If you're moving and suddenly hit a bump, your body tends to keep moving forward even though the skateboard stops. This happens because your body resists changes in its state of motion. The law of inertia is at play here, showing how objects naturally resist changes to their movement unless a force intervenes. Newton's second law of motion explains how the force applied to an object relates to its mass and acceleration. The law is often written as F equals m times a, where F is force, m is mass, and a is acceleration. This means that the greater the force applied to an object, the more it will accelerate. Conversely, heavier objects require more force to achieve the same acceleration. This law is crucial in designing vehicles, sports equipment, and even amusement park rides. Formula F equals m times a is central to Newton's second law. For example, if you push a shopping cart, low mass, and a loaded cart, high mass, with the same force, the lighter cart accelerates more. This relationship helps engineers calculate the forces needed in machines and vehicles, ensuring they operate safely and efficiently. Understanding this formula allows us to predict how objects will move when forces are applied. Newton's third law of motion states that for every action, there is an equal and opposite reaction. This means that whenever you push on something, it pushes back with the same force. For instance, when you jump off a boat, the boat moves backward. This law is fundamental in understanding how rockets launch into space and how we walk by pushing against the ground. Significance of Newton's third law goes beyond simple actions. It explains the mechanics behind swimming, flying, and even the recoil of a gun. When a swimmer pushes water backward, the water pushes them forward. This law is crucial in designing vehicles, sports techniques, and understanding natural phenomena. Recognizing action and reaction pairs helps us solve problems in physics and engineering. Forces can be balanced or unbalanced. Balanced forces occur when equal forces act on an object in opposite directions, resulting in no change in motion. For example, a book resting on a table experiences balanced forces. Unbalanced forces, on the other hand, cause a change in motion. If you push the book, the force you apply is unbalanced, making the book move. Understanding this difference is essential in analyzing how and why objects move. Friction is a force that opposes motion between two surfaces in contact. It's why you can walk without slipping and why cars can stop when brakes are applied. While friction can slow things down, it's also necessary for many everyday activities. However, too much friction can cause wear and tear, while too little can make surfaces slippery. Engineers often design materials and surfaces to control friction for safety and efficiency. Tension is the force transmitted through a string, rope, or cable when it is pulled tight by forces acting from opposite ends. For example, when you pull a rope in a tug-of-war, tension is what keeps the rope straight and taut. Tension is crucial in bridges, elevators, and many mechanical systems. Understanding how tension works helps engineers design safe and reliable structures. The principle of action and reaction forces is at the heart of Newton's third law. Whenever two objects interact, they exert equal and opposite forces on each other. This principle explains why rockets launch, birds fly, and why you move backward when you jump off a swing. Recognizing these force pairs helps us understand and predict the outcomes of various interactions in the physical world. Normal force is the support force exerted by a surface perpendicular to an object resting on it. For example, when a book lies on a table, the table pushes up with a force equal to the book's weight. This upward force prevents the book from falling through the table. The normal force is essential in understanding how objects remain at rest and how they interact with surfaces. Coefficient of friction is a value that describes how much friction exists between two surfaces. It depends on the materials involved. For example, rubber on concrete has a high coefficient, while ice on metal has a low one. This value helps engineers design tires, shoes, and machinery to ensure the right amount of grip or slip. Understanding the coefficient of friction is vital for safety and performance in many fields. Spring balance works on the principle that the extension of a spring is proportional to the force applied to it. When you hang an object on the spring balance, the spring stretches, and the scale shows the force in newtons. This simple device is widely used in laboratories and classrooms to measure weight and force accurately. It's a practical application of Hooke's law in everyday life. Pulley system uses wheels and ropes to lift or move loads more easily. The principle behind a pulley is to change the direction of the force applied, making it easier to lift heavy objects. Pulleys are used in cranes, elevators, and even window blinds. By distributing weight and force, pulley systems make work more efficient and manageable. Torque is a measure of the turning force on an object, such as a wrench turning a bolt. It depends on the force applied and the distance from the pivot point. The greater the force or the longer the lever arm, the more torque is produced. Torque is essential in engines, machinery, and even when opening a door. It helps us understand rotational motion and mechanical advantage. Centripetal force is the force that keeps an object moving in a circular path. For example, when you swing a ball on a string, the tension in the string provides the centripetal force needed to keep the ball moving in a circle. Without this force, the object would move in a straight line. Centripetal force is crucial in understanding the motion of planets, cars turning corners, and amusement park rides. Angular momentum is the quantity of rotation an object has, depending on its mass, shape, and speed of rotation. For example, a spinning ice skater pulls in their arms to spin faster, conserving angular momentum. This concept is vital in sports, engineering, and astronomy. It helps explain why planets keep spinning and how athletes perform spins and flips. The principle of conservation of angular momentum states that if no external torque acts on a system, its angular momentum remains constant. This is why a spinning figure skater can change speed by moving their arms in or out. In space, this principle explains why planets and stars keep rotating unless acted upon by another force. It's a key idea in understanding rotational motion in physics. Equilibrium occurs when all the forces acting on an object are balanced, resulting in no change in motion. There are two types: static equilibrium, where the object is at rest, and dynamic equilibrium, where it moves at constant velocity. For example, a book lying still on a table is in static equilibrium. Understanding equilibrium is essential in construction, engineering, and everyday life to ensure stability and safety. Stability of an object depends on factors like its base area, center of gravity, and weight distribution. A wider base and lower center of gravity make objects more stable. For example, a pyramid is more stable than a tall, narrow tower. Engineers consider these factors when designing buildings, vehicles, and furniture to prevent tipping and ensure safety. Lever is a simple machine that helps lift or move loads with less effort. It consists of a rigid bar that pivots around a fixed point called the fulcrum. By applying force at one end, you can move a load at the other end. Levers are used in seesaws, crowbars, and scissors. Understanding how levers work allows us to use force more efficiently in everyday tasks. Hydraulic lift works on the principle of transmitting force through a liquid. When force is applied to a small piston, it creates pressure that is transferred to a larger piston, lifting heavy objects with less effort. This principle is used in car lifts, elevators, and heavy machinery. Hydraulic systems make lifting and moving large loads easier and more efficient. Forces are at work all around us, from the moment we wake up to the time we go to bed. Whether it's opening a door, riding a bicycle, or playing sports, understanding forces helps us perform tasks more efficiently and safely. By applying the laws of motion, we can solve problems and innovate in fields like transportation, construction, and technology. Sports provide excellent examples of forces and motion in action. When a soccer player kicks a ball, they apply force to set it in motion. The ball's speed and direction depend on the force and angle of the kick. Friction between the ball and the ground slows it down, while air resistance affects its path. Coaches and athletes use physics to improve performance and prevent injuries. Vehicles rely on the laws of motion to operate safely and efficiently. Engines generate force to move cars, while brakes use friction to stop them. Engineers design vehicles to balance forces, reduce friction, and maximize safety. Understanding these principles helps create faster, safer, and more fuel-efficient transportation systems. Nature is full of examples of forces at work. Gravity keeps us grounded, wind moves clouds, and water flows downhill due to force. Animals use force to move, hunt, and survive. By studying these natural forces, scientists learn how the world works and develop new technologies inspired by nature. In this chapter, we've explored the fundamental concepts of force and the laws of motion. From Newton's 3 laws to friction, tension, and torque, these principles explain how and why objects move. Understanding these ideas not only helps us in science and engineering, but also in everyday life. By applying the laws of motion, we can solve problems, innovate, and make our world safer and more efficient. Keep exploring and questioning the forces around you.